All right, so today we'll start looking at trig. Okay, so chapters 6, 7, and 8, that's the bulk of the trig that we do in this class. And we're going to start out very basic just by looking at angles and how we measure them, and how we classify them and name them, things like that. So what I'll do is I'll just start out with very, very basic geometry. What is the definition of an angle? And an angle basically looks like this. Okay, what did I just draw there? I drew two rays. Okay? And the key is, when I drew them with a common starting point. Okay, if you just draw two rays like this, that's not an angle, that's just two rays. Okay, they have to have a common starting point. And does anybody know what that point is called? That's the vertex. Yep. So when we study triangles, technically a triangle, the sides are not rays, right? They're line segments. So when we draw a triangle, we still call these three things angles, even though they're not made up of rays, they're made up of line segments. Okay? But if we draw an angle all by itself, okay, not in a shape, that's generally how you draw it. Okay, two rays. Okay. There's two sides to an angle. Okay. There's this side, and there's that side. Okay. One side is called the initial side, and one side is the terminal side. And the way you can figure out which side is which is if you start at one side and go counterclockwise. If I just scroll down a little, you can see the picture. If I start at one of the sides and go counterclockwise between the rays, okay, kind of going between them, not on the outside of them. Okay, stay inside the two rays, go counterclockwise. You'll always end up at the terminal, and you start at the initial. Now, why did I write that there's really two angles here? There's this one.
There's the other one too, like if you go from the outside.
Yeah, so there's this small angle inside, which we'll give a name to it because it's less than 90 in a second. But then there's this bigger angle on the outside. Okay, when we're trying to find initial and terminal sides, you're always going between the rays the short way. Okay? So you would go like this. This is initial. This is terminal. Okay, so any questions on that? Doesn't matter how the angle is rotated. Okay, you always go counterclockwise between the two rays, not on the outside of them. Okay, so that's just naming the sides. Generally, we're going to be talking about angles that are less than 180, especially when we start tying it in with triangles. All the angles are always less than 180, and we'll talk about why. Okay, but we don't usually deal with angles that are like 250 degrees when we're talking about initial and terminal sides. Okay? We stick with angles that are smaller than 180.
How could you distinguish between an angle that is over 180 degrees and an angle that's not? Because technically, an angle does have two angles, one's on one side and one on the other.
They'd have to draw it. They'd either have to draw like this inside line or this outside line to show you which one they're talking about.
All right.
Yeah.
Where's the second?
Whereas the second angle is on the outside.
Oh,
Yeah. But we usually talk about the smaller angle, the one that's on the inside. And I'm going to give better names than smaller angle in a second. Okay, when we name angles in trig, a lot of times they use a Greek letter. Okay, just like in algebra, you use x a lot. Well, we use these letters a lot. Okay, these are not, we're not going to use all of these today, but you will see all of these between now and the end of chapter 8. Does anybody know the name of, we'll start kind of go in order here, this first Greek letter?
Alpha.
Yeah, that's alpha. And the second one is beta. How about that one? It looks kind of like a Y. Yeah, that's gamma. And then the circle with the line through the middle. Omega is the last one.
Epsilon.
Delta looks more like a D, or a triangle if it's a capital delta.
Weird 8.
These are all lowercase. Okay, there is capital alpha, capital, but we don't use those as much. These are the lowercase letters. Okay. This one is theta. And the last one is omega. Okay, if you've seen this before and you say, wait, isn't this omega? Yes, that's capital. We don't use that as much. We use the lowercase one a lot. Okay, so those are the 5 Greek letters you'll usually see when we're naming angles. Alpha, beta, gamma, especially when we do triangles. Theta and omega as well. Okay. Any questions on the names of those letters? Yeah, they're a little tricky, some of them, to kind of get used to drawing. Theta is pretty simple. But, omega does have kind of a loop in the middle of it. It looks kind of like a W, but the sides are curved in, and it kind of loops over itself a little bit.
I thought omega was like the horseshoe one. That kind of
We
looks
just talked about that.
That's a capital omega.
Oh,
Just
we
mentioned
just-
that.
so the-
Literally just mentioned.
These are all the lowercase. All right, so when we sketch an angle, like if I asked you to sketch a 45-degree angle, generally we like to put the initial side and the terminal side in a certain spot. So that makes everybody's 45-degree angle look the same. Okay. And the way we like to sketch it, it's called standard position. Okay. 2 things have to happen for an angle to be in standard position. The initial side has to be on the positive x-axis, and the vertex of your angle has to be at the origin. If you've done those 2 things, then you've drawn an angle in standard position. There's an angle that's in standard position. If I take it and go like this, is that angle still in standard position? No, what's wrong with it? Right, the initial side is still on the positive x-axis. That's okay. But the vertex isn't at the origin. Okay, what if I did this? Is that standard position? No. The vertex is at the origin, but the initial side is not on the positive x-axis. The terminal side is on the positive y-axis, but we don't care where the terminal side is. Okay. I only care where the initial side is and where the vertex is. So, any questions on what it means to draw an angle in standard position? All right. So we've talked a lot about how to draw angles, what the sides are called, their rays, initial and terminal, but we haven't really discussed yet how you measure an angle. Okay, we measure an angle in degrees. Okay, and this is a device you can use for measuring angles on paper. We don't really use it in trig that much. Does anybody know the device? Yeah, you can use a protractor. So like if you wanted to measure that angle in red, if you had a protractor, you just kind of drag it down, line it up, and you can measure the angle. Again, it's not really something we do a lot of. Okay, but that's the device you can use. Now, if you have an angle, okay, and you've got one complete revolution, okay, kind of think of like moving around a circle. Okay, it's a certain number of degrees to go all the way around. Does anybody know?
360.
Yeah, it's 360. And I can show you, I've got an example. I have an example, it's in that folder.
I think your folder's gonna open like 10 times.
Yeah.
I got this. All right, so let's just look at this. And what I'm going to show you is basically something I can drag, and I can create different angles. And they're always in standard position. Okay, I can move the terminal side, but the initial side is always on the positive x-axis. And it tells me the measure of the angle. Okay, as I start to move around the circle, okay, quarter of a way around the circle is 90. Okay, halfway is 180. 3/4 is 270. And then 360 all the way around. Now, you can tell the difference between 270 and -90, which we'll get into negative angles, maybe not today, but tomorrow, by the way this line is drawn. So somebody had asked me earlier, how can you tell if you're going outside or inside? Usually it's by drawing an arc, okay, when we draw the angle. Okay, and what happens if you go around more than once? What happens to your angle? Yeah, it just starts continuing on. So if you look at 450 and you look at 90, the terminal side is in exactly the same spot. It was straight up. So there's a special name between 450 and 90 degrees. They're basically the same angle. Okay? One just made an extra revolution. Okay? And you can go around as many times as you want. Okay, so those are all.
Keep going.
Yeah.
No, I can't go anymore. It doesn't. I didn't pay for the bonus features. Yeah. Okay, so I already kind of did this, but if you went halfway counterclockwise, how many degrees would that be? 180. Okay, so that would be 180. And if you went a quarter revolution counterclockwise, how much is that? That was 90. Okay, so anytime you're going counterclockwise, those are your angles. They're positive numbers. So angles measured in the counterclockwise direction are positive. If you go clockwise, okay, now you're measuring a negative angle. Okay, and I showed you that. So there's -90, -180, -270, and -360. And you might be noticing this other number below it. Anybody have a guess what that might be? That's radians. Okay, so we'll talk about that in a minute. Okay, so angles can be larger than 360 degrees or smaller than 0, or smaller than -360 if you make more than one revolution. Now, a lot of times we don't like to work with angles that are too big. Okay, so if you said to me, draw an angle that's 1800 degrees, off the top of my head, I'm not exactly sure where the initial and where the terminal side would be. So what I would like to do is make it smaller and easier to work with. So if you said 1800 degrees, okay, I could use this and figure it out. So 1800 degrees it's right there. So 1800, if I make it smaller, is really the same as 1440, which is really just the same as 1080, 720, 360, or roughly 0. Okay? So 1800 degrees is exactly the same angle as 0. And 0, it's a lot easier for me to visualize that in my head. Okay? So we'll talk about what to do if you get an angle that's too big, how you make it smaller. Or if you get an angle that's too small, how could you make it bigger? It just involves adding or subtracting a number. Does anybody know what number you can add or subtract? Like to get from negative 450 to negative 90?
360.
360. Okay, so adding and subtracting 360 to that number will land you back at the same spot. It just takes away a revolution or it gives you an extra revolution. Okay. Okay, and all those angles I was showing you where the terminal side lands at the same spot, those are called coterminal angles. So coterminal angles are angles that have the same initial and terminal sides. Okay, and all you have to do to find coterminal angles is add or subtract 360. Okay, so what we'll do is we'll sketch some angles in standard position, and then we'll find an angle that's coterminal with the one I give you as a positive, and then we'll find the one that's coterminal as a negative. Okay, but that's the key, just adding and subtracting 360. All right, so let's start with 30 degrees. Okay, if I ask you to sketch it, I'm not looking for a perfect sketch. I'm just looking, if you drew 30 degrees like this, I would mark that wrong. Okay, that's a little too big. So we just need to kind of get the terminal side in the right area. So where should the terminal side be if I'm going to sketch a 30-degree angle? Here's the initial.
Halfway is usually just a little less than halfway between the 90 mark.
Yeah, so if 90 is at the top, and this is 0, 30 is a little less than half. So maybe something about like that. Okay, so that's a 30-degree angle. And you do have to make sure you put that little circle on it if you're measuring in degrees. All right, so what would be an angle that's coterminal and positive? An angle that's coterminal to 30 and positive. So for the positive one, you would have 390. What about for the negative one? Yes. All those angles have the same initial and terminal sides. Okay, let's just let's do 30 and 390. Okay, so there's 30. So just visualize where that is. And there's 390. Okay. Any questions on that? Okay, how about 145? Let's see if we can just make a sketch first. Okay, so always put your initial side here. Where would the terminal side be? Let's just maybe start with the quadrant.
Oh God, I don't know much. I think
Yeah.
the first one. Wait.
Two.
Second one. Okay, it's going to be in the upper left.
Oh, that's the second one?
Yes.
I thought that was the first one.
Nope.
The first one on the right? Okay.
Let's think of positive.
Yeah.
Now what angle is straight up?
No,
That's 90. And what angle would be to the left? It's 180. What's halfway between 90 and 180? It's like add them up and divide by 2.
130, 140, 135.
135. Okay, so 135 is halfway. We're a little more than halfway. Okay, so maybe Now, just the best you can. Maybe about like that. Looks more than half. Okay, and there's our 145-degree angle. Okay, how would I find an angle that is, well, let's go like this, coterminal and positive, if I can move this down. Just want to move it down. There you go. Okay, what's an angle that's coterminal and positive?
505.
Okay, how did you get 505?
Added 360.
Added 360. So if we take 145, add 360, everyone agree that it's 505?
Yeah.
Okay. And now to find an angle that's coterminal and negative, just take 145 and subtract 360. Okay, and what do you get if you do that?
Negative 215.
Negative 215. Okay. So those are coterminal angles. How about negative 45? Okay, how would I sketch that one? Oh, John?
And stick it halfway between, well, halfway between 0 and 270.
Yeah. So it'd be about like that. And which way is your rotation when the angle is negative?
It'll be clockwise.
Clockwise. You went this way. Okay, so I'm going to put that arrow in there just to make sure people looking at it know I didn't go the other way. All right. So now let's find an angle that's coterminal and positive and coterminal and negative. Okay, so how would I get a coterminal angle that's positive, Sam? How are we finding all our coterminal angles in general?
Adding or subtracting, like the dots are 90 degrees and 90 degrees.
What's the certain amount that's important? You're going to add or subtract something that brings you right back to the same spot. 360. All right. So if we add 360 to that, you'll get 315 as your positive. And you could add it again and get another positive, and again, you could keep doing it. And then how about as a negative? How about Ethan, what do you get if you subtract 360? Yep, get negative 405. Okay, so any questions on finding angles that are coterminal? Generally, if you have to work with an angle, we like to work with the angle that's as small as we can get it, but not negative. Okay, so in this case, for number C, I would like to work with the 315. That's the smallest you can make it, but it's not negative. For A and B, I like the original angles the best. Okay, anything else is just bigger than it needs to be or negative. All right, so if we have angles that have certain measure to them, we give them special names. Does anybody know what an acute angle is?
Less than 90 degrees.
Okay, that's part of it.
Greater than 0, less than 90.
Yes. Okay, so that's an angle. Theta here represents an angle. Okay, so we have an angle represented by theta. If it's acute, it has to be greater than 0 and less than 90. Okay, so negative 10 is not an acute angle.
Does beta always represent an angle?
It's one of the letters you could use. I mean, you could use X, you could use Y, but a lot of times they do use a Greek letter for angles. Yeah. How about a right angle? Luke?
Equal to right angle.
Yeah, that's when your angle is exactly 90.
Wouldn't right angle also be like, the way negative 90 calculated?
If you measured it, if you were measuring it, yes, that is a right angle. But whenever these are all referring to measurements. So anytime you measure something, like think of a tape measure, your measurement has to be what kind of number? Positive. So really, we're just dealing with positive measurements.
Yeah, you really can't measure negative. You think about it.
Okay. Obtuse angle, okay, that's when you have an angle between 90 and 180 in degrees. And what about complementary angles? There's complementary and also look at supplementary. Yeah?
There are two angles that add up to 90 degrees, right? Complementary.
So how about negative 10 and 100?
Okay, two positive angles.
Yes. Two positive angles that add up to 90 degrees. So that example I gave of negative 10 and 100, those are not complementary. So another way you could say this is two acute angles, because acute automatically means it's positive. Two acute angles that add up to 90.
That might not necessarily mean it's 90.
What do you mean?
Like 40 and 30 are both acute angles, but they
Yes,
don't
but
have.
the definition is two acute angles that add up to 90
Oh.
degrees.
Yeah, if you just take the word positive and change it to acute. Okay, two acute angles that add up to 90. How about supplementary?
It's the same thing, except 180.
Yeah, two positive angles that add up to 180. Would they be acute?
Well, not, one of them could be,
Yeah, in fact, one of them would have to be,
unless they're two right angles.
unless they're two right angles. Okay, but you couldn't have two acute angles that add up to 180. That wouldn't make sense. But you could have one acute angle and an obtuse, or you could have two right angles.
You go up, you like,
Okay, so negative angles don't have complements or supplements. Okay, so if I ask you what's the complement of negative 10, doesn't exist. Supplement of negative 80 doesn't exist.
So negative angles will probably have obtuse or acute either.
No, if I said is negative 10 obtuse, acute, or a right angle, or none of the above, it is none of the above.
So just disregard negative angles
Yep.
for different stuff.
Yeah. Okay, any questions on that? Okay, so let's take a look and find the complement and supplement of 48 degrees. Okay, how would you find the complement of 48 degrees? What's the arithmetic you need to do?
Take the difference from
Yeah. Okay. To find the complement, okay, you have to have two angles that add to 90.
Oh, yeah.
So just take 90, subtract 48, we get 42. Okay, what about the supplement?
Just subtract it from 180.
Yeah. Take 180, subtract 48, and you get 132. All right, how about negative 18? What's the complement? Yeah, this one does not have a complement. How about supplement?
Same thing.
Remember, negative angles do not have complements or supplements. How about x degrees, assuming x is greater than 0?
90 minus x.
Yeah, the complement would be 90 minus x degrees
180 minus x.
and 180 minus x. So the last one is basically just generalizing the formula. Okay, take your angle and either subtract it from 90 or 180 to find the complement or supplement. Okay. Any questions on that? Okay, so we've given some special names, those terms like acute, obtuse, complement, supplement, and everything that we've done has been in degrees. Well, Degrees is fine if you're used to it. It works well. It's pretty easy to visualize because you've been doing it probably for a while. But radians is another way we measure angles. And throughout trig, we'll use both of these. Okay. So the last thing we're really going to try to look at is how do we change between radians and degrees. Okay, I'm going to start by drawing this picture. And what I've drawn here is a circle. And inside the circle, I put an angle, angle ACB, or angle BCA. You can read it either way. There's the vertex. It's at point C. And from point C, I have two rays coming out, ray CA and ray CB. Well, what happens is those rays come out, they hit the edge of the circle at 2 points. Yep. Those rays are both radii, assuming C is at the center, and it is. Okay. Where CA hits the edge of the circle, I just put a dot. And where ray CB hits the edge of the circle, I put another dot. If you connect between those two dots, okay, tracing along the circle, that's called an arc. Okay, and we read that arc AB. Arcs are not directional. They're not like A's, so you could call that arc BA. It's the same thing. But I just wanted to draw that picture so everybody can see what an arc is. And it's called an intercepted arc because it's where the rays intercept or hit the edge of the circle. Okay? And if you draw an angle, just like I did in the center of the circle, that's called a central angle. Okay? That's all a central angle is. It's an angle drawn inside a circle with the vertex at the center of the circle. Any questions on that? All right. So the first thing I'm going to show you, it's more of a geometry idea, is to kind of visualize what a radian would look like. Okay, how big would it be?
I think we touched base on this in Algebra 2.
You might have talked about it a little bit.
Yeah.
So if you look at the word radian, okay, radian almost looks like another word having to do with a circle. Radius. Okay, if you look at radians, radius, kind of spelled almost the same, and they're connected. So look at the size of this arc. Does the size of this arc and the size of the radius have to be the same?
Well,
No.
Assuming I change the size of the angle. No. Okay, you could draw an angle like this, and I would say that the arc now is probably a lot bigger than the radius. Or I could do just the opposite. I could make the angle very small, and the arc would become very small. Okay? So the size of the arc and the size of the radius don't have to be the same. But if they are, then you have drawn an angle that is exactly 1 radian. Okay? So if you drew this, took a piece of string and measured that arc, and then took a piece of string and measured the radius, if they came out exactly the same, then the picture you just drew is a picture of exactly 1 radian. Okay, so that's just a way to visualize what a radian would be. I haven't told you how many degrees in a radian. You'll be able to figure that out yourself once you know the formula. Okay, but that's kind of that's a visual. Okay, so any questions on that idea? Yep.
So this has to do with like circles that does like angles, right?
Oh yeah, when we talk about radians, we'll do a lot with
formula has
circles.
pi in it.
Yes.
I feel like it would.
Yeah, it has pi in it.
Yeah, so it's more circle.
And if you looked at the radian measure of certain angles, you saw pi in some of them.
Oh, I didn't see that.
Some of them it rounds to decimals. There's a pattern to which ones it's rounding and which ones it's leaving as decimals. All right.
Is it rounding
Did you
or is
know
it?
that?
Generally, angles that are multiples of 30, and actually any angle that's usually a multiple of 15, they usually write in terms of pi. It's like 15, 30, 45, 60, 75, 90. Those angles are written as pi. If you have an angle that's like 12.6 degrees, they usually don't. Okay? They usually round that off. All right, so let's take a look at how we can convert between radians and degrees. All right, so what I've drawn there, that's a special circle. Okay, it's a circle that has a radius of 1. Okay, if you draw a circle with a radius of 1, that's called a unit circle. Okay, we're going to spend a couple days talking about trig functions and unit circles. Probably, I don't know if we get to it this week. Probably not yet. But this is an important fact, and that's what's going to help us to figure out the conversion between radians and degrees. So in a unit circle, it says the radian measure of the angle, so in other words, if you measure the angle in radians, is equal to the length of the arc. Right? So in other words, if you gave me a circle that was 1 foot radius, okay, 2 foot diameter, 1 foot radius, if I were to measure an angle in that circle in radians, and then I took a piece of string and measured the arc, they would come out exactly the same. The size of the arc and the size of the angle are exactly the same number on a unit circle. So what I need to do is figure out a relationship between angle size and arc size. Okay? Kind of like if I said I want you to convert between feet and inches. As long as you know in 1 foot there's 12 inches, as long as you know this fact to start with, you can figure out any conversion you want. I could say how many feet in 73 inches. You could just set this up. Or if I said how many inches in 2.5 feet, you could plug 2.5 in for feet and leave inches as x. But you have to know something to start with. This is a relationship between measurement in feet and measurement in inches. If you don't know that, you can't do anything else. Okay? But you've got to know this conversion to start. Okay? So we got to figure out the conversion to start here. We have to know something. Okay? And you do. Okay, we're going to find an angle that we would already know the size of the arc length for. And that's going to help us to convert radians to degrees. Okay, you don't have to copy this second part. This part right here, this is just like thinking in your head. Okay, so we need to find an angle that we already know the size of the arc for. Right, so let's think of, draw a couple pictures and I think that'll help. Okay. There's a circle, let's pretend it's a unit circle. And I'm going to draw this angle right here. And there's my arc. How big is that angle in degrees?
Just like guessing.
90. And what's the size of the arc for a 90-degree angle? How much of the circle?
Quarter of it.
It's a quarter circle. Okay, let's go a little bigger. Okay, how much is that angle? That's a 180. And 180 degrees takes up how much of the circle? It's a half circle. Okay, let's go even bigger. Here's my initial side. Here's my terminal side. Okay, it's like I put them right on top of each other. How many degrees is that?
360.
So that's a 360. And that takes up how much of the circle?
The whole thing.
It's the whole thing. What do we call the whole thing?
The circumference.
It's the circumference. So now, if we know what the circumference of the unit circle is, We just said that the size of the arc is equal to the angle. So if you can tell me how big the circumference is, if you can tell me how big the arc is, that's how big the angle is in radians. Okay? So all we have to know is the formula for the size of an arc that goes all the way around a circle, or the circumference. So what's the formula for circumference of a circle? Mhm.
C equals pi r squared.
That's area, but close. That is for a circle. 2 pi r. Okay, now again, if you can tell me the size of the circumference, that number is exactly the same as the size of the angle. It's equal to the angle in radians, okay, because of that statement I just told you. So what is the radius on a unit circle?
Half.
1. Remember we said
Radius of a 1 unit circle.
the radius of a unit circle is 1 unit.
The radius was half.
A circle with radius 1 is a
Oh, okay.
unit circle. All right, so 2 pi times 1. So what's the circumference of a unit circle?
6.28.
6.28, or we could just leave it as 2 pi times 1. It's just 2 pi. Now, that's the circumference of a unit circle. What's the circumference the same as? The length of the arc, okay, which is the circumference,
At 360.
it's the same as, what does that say the length of the arc is equal to?
The radius measure of the sun's angle.
The measurement of the angle in radians. So now we know if 360 degrees goes all the way around the circle, how much would that be in radians?
1. Wait,
2
pi. I'm getting
pi.
confused.
Okay? The circumference is the same as the size of the angle. So if the circumference is 2 pi,
Oh, okay, yeah.
the angle is also equal to 2 pi. Okay? The circumference and the angle are exactly the same thing on a unit circle. And that's going to be our starting point. Okay, so now we know 1 revolution, it's 360 degrees, which you probably already knew that. But what we didn't know, or most of you probably didn't, is that 360 degrees is the same as 2 pi radians.
So to find it for the 90 degree, would you just multiply by 4?
Well, you don't even need, I'll show you, you won't even need to do that.
Okay.
Okay? So we could say 2 pi radians equals 360 degrees. 2 pi is 1 revolution in radians, 360 is 1 revolution in degrees. Or you can make it even simpler and say that pi radians is 180 degrees. So these two numbers, pi and 180, are the two numbers that you see a lot when you're converting between degrees and radians. You'll see a pi and you'll see a 180. Okay? And I'm going to show you 2 steps to converting between degrees and radians, or radians and degrees, involve the 2 numbers we just came up with. Okay? If you want to change from degrees to radians, you multiply by pi and you divide by 180. And I'll do an example. Okay. While you're copying it, I'll show you. If I want to convert from degrees to radians, I'm going to multiply by pi, and I'm going to divide by 180. Okay? And now I can simplify a little bit. How many times does 30 go into itself? And 30 goes into 180? 6. And now just after I reduce, multiply straight across. 1 times pi is pi. There's nothing in the bottom here, just a 1. What's 1 times 6? 6. And you don't have to label it. You don't put RAD. Okay? The only time you put a label on an angle is if you put the little circle. And that's for degrees. Okay, if I wanted to do this one, multiply by pi, divide by 180. How many times does 45 go into itself? And how many times does it go into 180?
4.
4. So 45 degrees is the same as pi over 4. Okay, and you can do a bunch of angles. Okay, and now to convert to degrees, it's just the opposite. You multiply by 180, and you divide by pi. So when I do this, what's going to cancel out here? The pi's cancel. And how many times does 2 go into 180?
90.
And you're left with 3 times 90, which is how much?
270.
Yeah. So 3 pi over 2 is the same as 270 degrees. Okay, and we'll practice some more tomorrow if we need to with degrees and radians. And if they wanted me to round something off, I would just type it in on my calculator, 2 times the pi button, and then divide by 3.
You go back.
Okay, so the homework tonight is on page 323. They're all very little quick problems. There's no long problems in there. And I know we only did like 2 or 3 converting, but we'll practice a lot more converting tomorrow. And I'll show you a way you can remember if it's pi over 180 or 180 over pi, because those are similar. And they're very easy to mix up. Okay, I'll show you tomorrow how you can remember it and get it right all the time.